Okay, so I'm going to do a couple of the names and formulas for the compounds that are what I call the switch hitters, which are compounds that contain ions of the transition metals. Okay, so here's a couple of examples. Okay, if you have this formula right here, CUF, okay, first of all, when you look at that for the first time, you need to decide what is the general form for how that's named. What you might want to take a look at is this little naming flow chart. Okay, first question here is, does it contain a metal? All right, if you look at Cu and F, all right, copper here, if you look at it on the periodic table, that's one of the blue elements, so that's a metal. So yes, it contains a metal. The next thing it asks is the metal a switch hitter? Okay, if you look at page 9 in the blue reference guide, right, is copper one of the elements that's represented there? Yes, it is. What this says is that there's two different types of copper ions. There's the copper +1 and the copper +2. So what this tells you is that when you're naming this compound, since yes, it is copper is a switch hitter, that you're going to need to name it with the Roman numerals in the middle. Okay, so we know off the bat that this guy is copper, and his last name is fluoride. Okay, but he's going to have a middle initial here, and the middle initial corresponds to what is the charge on that copper ion. Okay, and the way I always tell people to do this is to do a little seesaw, where you're going to say this is the negative side over here, and that the negative side has to be balanced by the positive side right there. Okay, so if you look at this formula, how many of the negative ions do you have? So how many fluoride atoms are there? There's only one of them. Okay, and what is the total amount of the charge on that single ion? Well, fluorine makes a -1 ion. All right, that's fluoride right there. Okay, so what is the total amount of negative charge from that guy? It would be -1. All right, that's got to be balanced by the amount of positive charge by the positive ion. All right, what is the positive ion? It's copper. All right, and how many coppers are there? All right, even though the ones are not drawn in here, whenever you have a formula where there's no number after it, you assume that there's only one of it, just like H2O. That means 2 hydrogens and 1 oxygen. So there's 1 copper, all right? And that 1 copper has got to come up with a total of +1 charge. So it's got to pay the entire bill since there's only one of them. So that guy is +1, all right? So what this would mean is that CUF is copper Roman numeral 1 fluoride, where that Roman numeral 1 comes from the fact that that is a +1 charge on that particular atom. Okay, Cr2O3. Okay, this means 2 chromium atoms, 3 oxygen atoms. All right. If you take a look at the flow sheet, does it contain a metal? Chromium is the metal, so it's yes. Is chromium a switch hitter? All right. If you look at this little list right here, is chromium on that list? Yeah, there's 2 versions. There's chromium +2, there's chromium +3. Okay. So when we name this, we know it's going to be chromium with some Roman numeral in its in the middle, oxide. All right, and how do you figure out what that charge is or what that Roman numeral is? It's going to be the charge on the chromium atoms here. Okay, so again, draw the little seesaw. Okay, start with what you know, all right? How many oxide ions are there? All right, this formula says that there are 3. Okay, and what is the charge on that? You should know by now that because of oxygen's position on the periodic table, he's always got a -2 charge. All right, if you've got 3 atoms that each have a -2 charge, that means that together they make a total of -6. All right. So if there is a -6 charge over there, in order to balance that out, there's got to be a +6 charge over here. And so what you're going to say is, all right, well, what is going to be able to make that +6 charge? All right, my positive ions here, I've got 2 chromiums. All right, well, if you've got 2 chromiums which together need to come up with a total of +6, it's like saying they got to split the bill. So each one's got to have +3. Okay, and so what would be the Roman numeral here? It's whatever the charge is on that ion, all right? So that's +3. So you needed to have a Roman numeral 3 there. So one last example. This is actually an example that's not on the worksheet that you were doing on this originally. It's one that I just made up. So SN2P4, okay? So first of all, does it contain a metal? Yes, tin is a metal. So is SN, which is tin, is that a switch hitter on the sheet? Okay, yes, tin is one of those ions. So it's yes, so you need the middle initial. So this is going to be tin phosphide. All right, and this guy needs a middle initial. So do the little triangle. How many phosphoruses do you have? You have 4. Okay, each phosphorus, when phosphorus makes an ion, it's -3. Okay, so if you have a total of 4 -3s, that means you've got a total of -12 total minus charge. All right, so if it's got a total of 12 minus charge, it's got to have +12 in order to balance that out, okay? How many tins are there? Okay, there's 3 separate tins here. All right, so here's the logic. If there's 3 separate tins and they've got to split the bill of 12, then each one's got to come up with +4. Okay, so the Roman numeral that goes there has got to be 4. All right, so that's what his name would be. Okay, so before we were going from a formula to a name, now we're going to be turning that around where you're going from a name to a formula. Okay, so these are going to be all the types where you've got a Roman numeral in the middle. All right, and those are for the types of ions for the types of elements where it can either make one type of an ion or another. Okay, so by the way, some of these are not on the list of switch hitters that are in your reference guide. So you can assume that if something's got a Roman numeral in the middle, that it is a switch hitter. Okay. Okay, so something like this. all right? What this does, what that Roman numeral tells you is the charge on that guy, okay? So we know that this guy is Mn. We know that his charge is +7 because Roman numeral 7 there, all right? Oxide, all right? We know that oxide is oxygen with a -2 charge, all right? Crisscross rule, Mn2O7, okay? Titanium 3 phosphide, okay? Again, this right here is the charge on that metal, all right? Titanium is Ti, all right? That Roman numeral 3 tells me that there's a +3 charge on it. Phosphide, we know that phosphide is -3, okay? Okay, titanium 3, phosphorus 3. Okay, so just like with the ionic compounds before, if there's a simpler ratio than the one shown here, this is a 3-to-3 ratio, that is the same thing as a 1-to-1 ratio. Come in. Okay, so a 3-to-3 ratio can be simplified to a 1-to-1 ratio. So you end up simplifying it to this formula right here.